We stand at the cusp of a new era, an era of remarkable technological advancement. Robots are rapidly becoming an integral part of our reality. From manufacturing and healthcare to exploration and everyday life, robots promise to reshape our world. But this future is not without its challenges. These challenges are technical, ethical, societal, and philosophical. It requires a global conversation to ensure the robotic revolution benefits all of humanity. Security is paramount in the world of robotics. Imagine a surgical robot being compromised during a delicate procedure, or a self-driving car veering off course due to a malicious attack. The consequences could be catastrophic. Robots, like any computer system, are vulnerable to hacking and cyber attacks. Hackers could potentially gain control of robots, accessing their sensors, data, and even their physical capabilities. This could lead to data breaches, privacy violations, and even physical harm. Protecting robots from such threats is crucial. We need robust cybersecurity measures to safeguard robotic systems from unauthorized access and malicious intent. This includes everything from secure communication protocols to advanced encryption algorithms and intrusion detection systems. The safety and trust that underpin the success of robotics depend on our ability to build secure and resilient systems. By prioritizing security, we can unlock the full potential of robotics while mitigating the risks. Robots, especially those equipped with artificial intelligence, collect and process vast amounts of data. This data can include personal information, sensitive environmental data, and even confidential business information. Protecting this data is not just a technical challenge, but also an ethical imperative. Imagine a home robot inadvertently recording private conversations or a delivery robot leaking sensitive customer data. These scenarios highlight the importance of robust data privacy measures in robotics. We need clear guidelines and regulations for data collection, storage, and use by robots. Data encryption, anonymization techniques, and strict access controls are essential to protect privacy and prevent misuse. Transparency is also key. Users have the right to know what data their robots are collecting and how that data is being used. By embedding privacy by design principles into robotics development, we can foster trust and ensure the responsible use of data in the age of intelligent machines. Robots are often designed to operate in controlled environments such as factories or warehouses. But as robots become more sophisticated, we expect them to navigate the complexities of the real world. This transition from controlled environments to unstructured dynamic spaces poses significant challenges. Imagine a disaster response robot navigating the rubble of a collapsed building, or a delivery robot encountering unexpected obstacles on a busy sidewalk. These scenarios require robots to perceive, interpret, and react to unpredictable situations in real time. This requires advanced sensors, robust algorithms, and a degree of adaptability that goes beyond traditional programming. Robots need to learn from their experiences, adapt to changing conditions, and make decisions in real time to operate effectively in the wild. The ability to operate effectively in unstructured environments is crucial for robots to reach their full potential in real-world applications. Section 5. The Balancing Act: Precision versus Adaptation. Traditional robots excel at precision. They follow pre-programmed paths and execute tasks with unwavering accuracy. This precision is invaluable in controlled settings like manufacturing. But in the real world, adaptability is just as crucial as precision. Imagine a robot trying to grasp a delicate object or a robot assistant navigating a crowded room. These tasks require a level of dexterity and adaptability that traditional robots often lack. Finding the right balance between precision and adaptation is one of the key challenges in robotics. Robots need to be precise enough to perform tasks reliably, but also adaptable enough to handle unexpected situations and variations in the environment. This requires a combination of advanced sensing, intelligent control algorithms, and new materials that can mimic the flexibility and dexterity of living organisms. Section 6. The Power of Learning Towards Adaptive Robotics. One of the most promising avenues for enhancing robot adaptability is machine learning. By leveraging the power of data and algorithms, robots can learn from their experiences and improve their performance over time. Imagine a robot that learns to grasp different objects by trial and error, or a robot that improves its navigation skills by analyzing data from its sensors. This ability to learn and adapt is key to unlocking the full potential of robotics in complex and dynamic environments. Machine learning enables robots to handle uncertainties, adapt to changing conditions, and even generalize their knowledge to new situations. This opens up a world of possibilities for robotics, from personalized assistants to self-driving cars and beyond. As robots become more intelligent and adaptable, they will be able to take on a wider range of tasks, collaborate more effectively with humans, and ultimately enhance our lives in countless ways. Section 7. Ethical considerations in a robotic world. The rise of robotics raises profound ethical questions that we as a society must address. As robots become more sophisticated and autonomous, we need to consider their impact on human autonomy, privacy, and well-being. Should robots be allowed to make life or death decisions? How do we ensure that robots are used ethically and responsibly? These are not merely hypothetical questions. They are real-world dilemmas that we need to grapple with sooner rather than later. We need to establish ethical guidelines for the development and deployment of robots, ensuring that they are aligned with human values and do not perpetuate existing biases or inequalities. This requires a multidisciplinary approach involving ethicists, philosophers, policymakers, and technologists working together to shape the future of robotics in a responsible and beneficial way. The ethical implications of robotics are complex and far-reaching. By addressing these issues head-on, we can harness the power of robotics for good while mitigating potential risks. Section 8. The impact on employment and the economy. The rise of robotics will undoubtedly have significant implications for the future of work. As robots become more capable, they will inevitably automate certain jobs, potentially leading to job displacement in some sectors. However, it is important to remember that technological advancements have always disrupted labor markets throughout history. The Industrial Revolution, for example, led to the decline of certain crafts but also created new industries and job opportunities. Similarly, the rise of robotics is likely to create new jobs in fields such as robot design, engineering, maintenance, and operation. It is also likely to fuel innovation and economic growth, creating new markets and opportunities. The key is to prepare for these shifts by investing in education and training programs that equip workers with the skills they need to thrive in a robotics-driven economy. By embracing lifelong learning and fostering a culture of adaptability, we can navigate the challenges and opportunities of the robotic revolution. Section 9. A future shaped by robots: utopia or dystopia. The future of robotics is a topic that has captured the imagination of writers, filmmakers, and futurists for decades. Some envision a utopian future where robots free us from mundane tasks, allowing us to pursue more creative and fulfilling endeavors. Others warn of a dystopian future where robots displace human workers, exacerbate inequality, or even pose a threat to our very existence. The reality, as is often the case, is likely to be more nuanced than either of these extremes. Robotics has the potential to both improve and disrupt our lives in profound ways. The future of robotics is not predetermined. It is a future that we are actively shaping through our choices and actions. By embracing a future-oriented mindset, fostering collaboration between academia, industry, and government, and engaging in thoughtful dialogue about the ethical implications of robotics, we can harness the power of this transformative technology for the betterment of humanity. Section 10. Bridging the gap: collaboration for a robotic future. The challenges and opportunities presented by robotics are too complex for any one entity to address alone. We need a collaborative approach, bringing together the best minds from academia, industry, and government to shape the future of robotics in a responsible and beneficial way. Universities and research institutions play a crucial role in advancing the fundamental science and engineering behind robotics. Companies are essential for translating research into real-world products and services, and governments play a vital role in establishing regulations, setting ethical guidelines, and fostering public trust in robotics. By fostering collaboration and knowledge sharing, we can accelerate innovation, address ethical concerns, and ensure that the benefits of robotics are shared widely. This collaborative approach is essential for unlocking the full potential of robotics and creating a future where robots and humans coexist and thrive together. Section 11. To infinity and beyond. The uncharted territory of robotics. The field of robotics is still in its infancy. As we venture further into the uncharted territory of robotics, we can expect new challenges and opportunities. The future of robotics is not predetermined. It is a future we shape through our choices and actions.